Welcome to the office to have some fun with Kubernetes and drink some non-alcoholic beer. My name is Burak. I build software at Twilio, and today we will talk Kubernetes or Kubernetes. So, what will I be talking today? So I have heard that actually there are a lot of people who are interested in Kubernetes as a concept. They want to know about Kubernetes. They are interested, but they want to get a little bit more familiar with it, basically. So what I will do is, instead of diving directly into my project discussion, I will first do a recap of Kubernetes. Then I will talk about a specific project that I designed and built using Kubernetes. And then we will talk about the learnings that we generated in that domain. And that learning will be specifically focusing on the learnings from a point of view of developer experience. So, etymology of that concept. So this is a Greek word, basically. And when you think about it, it means a ship pilot. It also means governor and stuff like that, which we are not interested in. So the concept means ship pilot, helmsman, if you will. So if you pronounce this in Greek, it would be Kubernetes. Why does it have that logo? Because basically it is an analogy of driving in the unknown area of distributed systems. So that analogy is basically the sea, an ocean. So we are trying to drive through, and obviously we are a ship. So we carry containers, right? So this is basically what Kubernetes is coined for. So the other entity that you see in the down part means abstraction. Why did I put it there? Because it looks cool, basically. It's just Greek abstraction. But why abstraction? Because as you probably know, this is a complex entity. So to understand it in detail, actually, so most of us are probably engineers. So what does it even mean? Like containerization or orchestration tool, what does that mean even? So when I learned something new, I try to approach it as a point of abstraction. So why do we define abstractions in computer science? This is a philosophical question. But in this context, if we treat Kubernetes as an abstraction that we define to our infra, to invert the dependency to the infra, then it means that rather than we depending on infra, infra will depend on us, if we do it properly, obviously. So this is what I will be generally talking about today, Kubernetes as an abstraction. What do we mean by that? So what I will do is to first try to identify that Kubernetes as an algebra. So what does that even mean? So when we learn something new, a system, a framework, anything, if this is a technical field, it is gonna have an algebraic structure. This is rather a generalization. Again, a philosophical one, but I think we can use it for practical purposes. So an algebra will always have basic entities and relations between those entities. So what does it mean to make sense in that algebra? It means to understand the relationships between those entities. So this is what we will try to do. And then we will talk about Kubernetes as a facilitator, as a technical facilitator that we use to solve technical problems. What kinds of entities it gives us, and why, and how do we use them? And then finally, we will talk about Kubernetes as an asset. And this is from really the financial asset aspect, if you will. So to use an asset to your advantage, you have to manage risks to get the rewards. So this is what the product point of view will be like. Moving on. So Kubernetes as an algebra. So objects and relations it has in its core. So this is what the generic structure of Kubernetes look like. It is impossible to theoretically put everything in Kubernetes here because As per definition of Kubernetes, it can be self-generative. So you can generate new entities in Kubernetes. However, the most important entity here, as you can see, the core entity is what we name as a pod. So this pod is the basic unit of deployment in Kubernetes. We are interested in pods. Pods can be an analog of virtual machines, but this is not virtual machine. There are no hypervisors here, obviously, but the analog holds. So everything in Kubernetes is either a pod or uses a pod, manages a pod. Basically, this is the unit of deployment. And obviously that pod will contain the container, in turn, which will contain the code that we write, right? So you can also see an important structure here as deployment, basically. So we use that usually in production to make the deployment. That is called a deployment entity, an object or resource. We also have replica sets and services, for example. Service is another entity that will touch on. So the main unit atomic entity in this algebra is a pod, not a container. Moving on. What does the Kubernetes architecture look like? So Kubernetes basically gives us an overview, let's say, of the whole infrastructure as a single point of entry that we can use and manage. It doesn't matter where that cluster partially lives. As I will tell you about, so that cluster will be partially on-prem. It can be on AWS, it can be on any other service provider, it doesn't really matter. Using Kubernetes, if we do it properly, we will invert this dependency and we will be able to manage that infra however we want to, without depending on constraints provided by providers, cloud providers. So we have a control plane, a master node, and several worker nodes. Basically, this is how the general structure is like. Moving on. How do we deploy something to Kubernetes? So we basically use a descriptive approach. This is a core idea in Kubernetes design. We don't tell Kubernetes how to do what. We just tell Kubernetes what we expect of them. So this is a basic idea that we use in functional programming, for example. So we delegate the responsibility to Kubernetes that way. So this is not by chance. Kubernetes is designed that way because when you look at the documentation of Kubernetes, you will actually see one of the founders is saying something like, we aim to make Kubernetes and deployment of large-scale applications a CS101 exercise. This is the aim. Can it do that? This is another question, but this is the aim. And being descriptive is basically at the core of this idea. So we write a YAML file and we tell API server, which is here, we call our command and then we try to do the deployment. We make Kubernetes do that deployment for us. So it also obviously uses a container runtime in worker nodes. It doesn't have to be Docker. Docker is not a container runtime, but it uses a container runtime called runc. That is the daemon responsible of running and managing that container entity. So Kubernetes has to have usually a container runtime to run the containers, but it doesn't always have to be Docker. So moving on to the pod. So as we said, that pod is a primitive entity in Kubernetes. What does a pod mean in general? Why do we need pods? Why do we embed containers in pods? So taking a step back and considering the idea of microservices here. In general, when you are using containers, we usually do what is called basically one main process, let's say, per container, right? We don't usually deploy multiple distinct processes to a container, except for when it is a helper process. So that container is basically a realization of one problem solver, which is not tightly coupled to any other container if designed properly. So pod entity takes these containers and manages the containers with the same idea. So what we usually do is that pod is a first-class citizen in the world of Kubernetes. What do we mean by that? It is uniquely identified by an IP address at all times. If you do not put the proper controls in place, any pod will be able to communicate with any other pod. There's a direct transport layer between them, basically. That is how it is designed. And usually one pod in the same manner will contain one main container and several other helper containers if you need them, basically. But if you try to add multiple distinct containers to a pod, you lose most of the advantages that Kubernetes provides in terms of high availability, because we put only the entities that need to scale together to a pod, as we do for the processes to containers. If they do not scale together, we don't usually put them to the same pod. As you can see, pods will have distinct IP addresses, and there can also be supporting containers that we can deploy. But we don't usually deploy pods directly. What we use during the deployments is what we call a ReplicaSet, which is a second generation version of replication controller. So they have the same idea, but replication controller is kind of deprecated now. What is that entity? So it is basically a wrapper that provides high availability in Kubernetes. If the pod is problematic, replication controller objects, resources for which we write the YAML for and deploy, will handle that. It has innate readiness probe, liveness probe, and it is the basic provider of that high availability idea in Kubernetes. So when you look at it, then you actually look at the source code and how it is written. It is a controller, basically, controller class. When you check it, you will see that there is a basic loop. It is called the reconciliation loop in Go. It is actually a primitive, a package in Golang that you use. So when you hear about the things like in industry, like I have decreased my deployment time for 2,000 containers to 10 seconds, thanks to Kubernetes. That reconciliation loop is the main culprit most of the time because of its innate efficiency. And obviously, thanks to Golang too, partially. So we don't directly put the pods. If we do, if the pod dies because they are ephemeral, they won't come back if there isn't a controller on top of them. So we also have what we call a service. That service is another crucial entity that needs to exist most of the time in some form or another in our deployments. Why? Because, as I said, pods will always be ephemeral. So they can go out of scope, they can die, they can get into the scope suddenly because of other controllers, regeneration and stuff like that. So we need to use a service to identify a set of pods. So that service is actually a representation of a set of pods. So it is responsible of those set of pods in terms of giving them, assigning them a static IP as an analogy. So you use that static IP to reach out to those pods. You don't directly usually go to the pods themselves because you don't know when the pod is going to be there. This is how Kubernetes is designed. If you are trying to explicitly reach out to the code of, somehow pod, you are definitely doing something wrong because it is not defined that way. You need to use a type of service to do that. As you can see, we write the YAML and it is a kind of service. So we deploy that YAML and then we generate a load balancer. Load balancer is an external service that we usually use to generate external egresses, let's say, to the outer world. And node ports are usually the internal ones, but there are 1,000 of different types. You can also generate your own types of custom services too. Moving on to the deployment, as I've talked about, previously, deployment being declarative is a core design idea in Kubernetes. So in that way, this is another way of inverting the dependency here. We delegate the task of deployment to Kubernetes itself reliably, so to speak. So this is what our expectation is. We don't tell anything in terms of how it should do step by step. We just tell them what to do, what we expect. So as I've said, they have innate readiness and liveness probes to manage that deployment. We usually add replica sets or replication controllers to our deployments, which in turn manage pods. So we don't really directly in production code, I mean, we don't really deploy codes directly most of the time. So Kubernetes is extensible. So this is going to be the main idea that we will discuss. But this extensibility is actually needs to be treated generally as a double-edged sword because it generates risks. So most of the time, that extensibility and flexibility will be the culprit of most infras in testing stage to fail. So it asks you to basically, it pushes you, Kubernetes pushes you to manage that risk explicitly. You have to include that in design. If you don't early on, then we see all those types of problems using Kubernetes. If you do, you will get the reverse probably. So wrapping up, we talked about pods. We said that pods would contain containers. So pod is the main identity of Kubernetes. It is the main atomic entity in Kubernetes, which everything else is related to some way or another. So this is the core idea. So we deploy pods, right? But we do not directly deploy pods. There are going to be services, deployments. We need to use replication controllers, ReplicaSets, and stuff like that. This is what the general algebra of Kubernetes looks like. So moving on. Kubernetes as a facilitator, what do we mean by that? So if we try to abstract the idea of Kubernetes from an engineering perspective in terms of what it provides us as a technical tooling, set of technical tooling, solving engineering problems, we can talk about a specific example that I designed and built most of with that application. So imagine we have a US bank, and that bank has several users. What we mean by users here, it is a concept, it can be anything. It can be account, it can be API, it can be a service account, it can be a real user. It is a type of an identity, basically. So that bank is requesting a separate infrastructure, which has to be, which has to satisfy a lot of hard security constraints. So they are requesting a multi-tenant infra, but the problem is that infra has to compose of several different services, which all have to be Kubernetesized, let's say. So some of those services are on-prem, some of those services are on AWS, some of them are in Google Cloud. So I can't really touch them. I have to add a Kubernetes wrapper to everything because they want a multi-tenant, hardly secure infra that they will migrate everything to. So what I did here is the customer basically has on-prem hardware security models they want to use to generate the tokens as per the basically their hard constraint of internally signing every action and every identity and generating those tokens and assigning identities to roles and stuff like that. So there is also another service, which is the token generator. This is OAuth 2 tokens, basically, that I use to generate and somehow relate to the cryptographic keys during signing phase. We also have API for accounts. These accounts are bank accounts, let's say. So you can think of them as bank accounts. So these accounts should perform only the necessary actions that they can without touching anything else in that multi-tenant environment. The problem is the customer has 16 high-value customers. So all of them have to be separate tenants, and the other set of, let's say, non-high-value customers should be one set of tenants in the app, and they have to be living happily ever after, let's say, without touching each other, anything else. And also there's all LDAP, as you'll see here. So we needed to also implement that LDAP service too, because Kubernetes does not have an internal ID of a user, which holds for tenants too. So Kubernetes you won't find that tenant entity internally supported. You have to generate it yourself and write your infra code accordingly. So we also have a DB, which is also on-prem. So using Kubernetes, what I did is basically to somehow deploy all of those clusters, separate clusters, but the master node, the control layer was in on-prem of the customer. But the parts of the clusters were on AWS, on Google Cloud, wrapping up all those services to make them secure. So what did I use to achieve that? What are the native Kubernetes entities that I have to use to achieve that security and multi-tenancy? So there's a namespace entity in Kubernetes, which is the source of, most of the time, the core of supporting that idea of multi-tenancy. However, although it provides that foundation, it doesn't impose any hard constraints. So that is the idea. In Kubernetes, you will most of the time see a lot of similar stuff. So it'll be extensible, it'll be powerful, but it'll mostly depend on how you use them. So there isn't much constraints out of the box most of the time. So you can use namespaces, and what you do with namespaces is you add an ownership, let's say, ownership entity to some Kubernetes resource. It can be a pod, it can be a service, it can be a cluster partially, it can be anything. You can put them in namespaces. However, it is a logical construct. And if you don't put the necessary checks, this is what happens. So I actually saw a lot of frustration during my design and development. People are trying to use namespaces, but they somehow expect something from them, but it doesn't work. But when you check how it is written, actually, it doesn't say anything in terms of hard constraints. So Kubernetes generally pushes you to understand what you are doing. If you don't do that, there will be a lot of risks. And since this is an infra, we can maybe generalize and say that those risks will create such technical debts that it'll be very hard to pay later on, plus the interests, like it is going to be hard. So what else did I use? I used an innate ability of role-based access control in Kubernetes. So what this guy does is, after you generate tenants programmatically, you generate ID for them, you uniquely identify them, and you can use that RBAG to assign roles, bind roles to those tenants. So it basically provides an API server layer authorization. What was the API server? Basically, API server was what we initially communicated with when we are running some Kubernetes command, let's say, generally speaking. So because of innate abilities of Kubernetes in terms of providing RBAG, we can bind specific edit, change, admin, role, stuff like that, or view, so that the tenants do not touch each other's resources. We also have what we call as resource quotas. This is another primitive that I use to achieve this multi-tenancy. Basically, it can limit two kinds of entities. One is the compute resources, actually. So it can limit how much compute resource a tenant can use per namespace. It can also limit how much objects and Kubernetes resources, such as pods, services, a tenant can create in a namespace. So you generally can control the quotas of resources that are being generated per tenant. What else did I use? There's also an entity called admission webhooks. So what they do is, let's say you are writing a YAML code to deploy something. So you can use those admission webhooks in such a way that each tenant has to have a owner label. Let's say if there isn't an owner label on those deployments, they will be rejected. They will not be run at all. They will not be admissible. So those are the webhooks. This is another primitive provided by Kubernetes. Basically, you can just use it out of the box. Okay, what else? So network policies. Usually, I said in the beginning that it is possible to communicate each pod with each other, no matter where the namespace is, where the pod lives. So it is flexible. However, if you want to achieve multi-tenancy, this is not going to be accepted by any of your customers. This is just not possible. So what I did in that case is start with a principle of least privilege idea immediately. So I rejected each tenant from reaching out to themselves like immediately, ground zero. And then I explicitly tried to open ingress and egress ports and then build what we call as ingresses, as an advanced version of a service you can think of them. They are not specifically services, but you can think of it that way. So poking holes in each tenant after applying those principle of least privilege, denying everything, I explicitly had to manage all those ins and outs of each tenant and all the namespaces they use. So we also have pod security policies. If you check OWASP, you will see a lot of security vulnerabilities for Kubernetes, especially in control plane. So this is rather dangerous. So what I had to do is to apply that idea of pod security policies too. This is another primitive that you can use when generating your multi-tenant applications. So basically, it controls the runtime parameters of pods. So what can it run? How can it be run? Can you run it as root, for example? What if there is somehow a problem, a security vulnerability that a high-value customer's pod is being dismissed by a low-value, let's say, customer's pod because the runtime has been hijacked? There are like a lot of weird stuff that has been done in Kubernetes. I recently saw some usage of cryptographic mining in a big Kubernetes cluster. And now it is a security vulnerability, for example. Because it is powerful, people tend to try to do that. So finally, obviously, we need to log everything, by everything except PII, obviously. So, but what I tried to do is we had a Prometheus solution out of the box, so I wanted to use that. However, Kubernetes does not support multi-tenant Prometheus. However, it says that you can extend it if you want to. So we see that there's another entity, Prometheus operator. So there are operators in Kubernetes. They are kind of a human operator, but an automated version, if you will. So we used Prometheus operator, and that actually supports out-of-the-box multi-tenancy. So it was that easy, basically, except for the pain in deployment, obviously. So as you see that Kubernetes supports a lot of entities out of the box, but I had to do most of them manually because of the hard security constraints imposed by the bank. This is a bank, and that project actually that I talked about has tens of millions of active daily users. So you can't go to the customer and say that, hey, I have a hierarchical namespace controller which provides a lot of multi-tenancy out of the box, which is the case. You can say that because all of the features, most of the features that you want to use was in either alpha or beta stage. So I couldn't use that mostly, but it is probably more mature now. So to actually support most of the things that I mentioned, you can just use hierarchical namespace controller, which is a special interest group. And it is basically under the working group of multi-tenancy. It supports solutions for multi-tenant applications. So moving on, Kubernetes as an asset. So idea is, apart from the technical out-of-the-box entities Kubernetes provides to solve a lot of different secure, multi-tenant, requirement-satisfying applications. When we consider Kubernetes as an abstraction from a product perspective, so what do we see? We immediately start with this. So you'll see that this is most of the time the sentiment of people. That is subjective, but that is what I heard. That is what I observed. So you said all I needed was a YAML file. Well, people expect, because Kubernetes is powerful, they expect it to solve a lot of problems by just declaratively running YAML files. However, as I've tried to discuss, Kubernetes forces you to understand what you are doing. If you don't do that, there are going to be problems. So most of the time as developers, what do? We just don't even read the documentation because we don't need to most of the time. Like, if there's something that we don't know, it is fun. We will do it anyway. We will try it out. Most of us do it. I mostly do it myself, basically. So I don't start with reading the documentation. I just get my hands dirty, and most of the time it works. In Kubernetes, however, as I said, it forces you to explicitly understand what you are doing. If you don't do that, there are going to be a lot of problems, because trial and error is not really the idea. Because this is a frustration, basically, you can see, because it happens because of expectations. When you get frustrated is when you don't have the reality matching your expectations, right? So this sentiment of the general Kubernetes user base is basically most of the time is exact opposite of what it is supposed to be, because Kubernetes is flexible, it is expressive, but you need to understand what you need to do. It forces you to do that. Actually, now that I think about it, that you can also see that if you use Golang, this is a similar idea. So you can say that, hey, I will use Golang because X, Y, Z. However, if you are not really comfortable doing whatever you do with, let's say, pointers, for example, as a simple example, there are going to be problems because the language allows you to do that because it is performant. But you have to understand explicitly what you are doing. You can't blame the language for that. So, and what we learned in this project, in the process of this project, is to explicitly manage those risks. So an asset is only a rewardable entity, let's say. It is something good for you, let's say, if you properly manage the risks. If you don't do that, what are you going to say when you enter the stock market, like it all crashed and you didn't manage, you didn't hedge, let's say? Are you going to blame the stock market? You can, but that is on you, basically. It doesn't work like that. The same idea holds in Kubernetes too. You need to understand what you are doing and what you are not doing and why. So this was the idea of basic learning. So this is another sentiment that really clearly explains what the Kubernetes is like. You'll see that features implemented is skyrocketing using Kubernetes. It is most of the time the case because it is expressive, as I mentioned. However, there are going to be problems if you don't manage the risks. So if you treat this as an asset, as I have learned, like if you treat it as an asset that you explicitly need to manage the risks of before starting the design and throughout managing that risk, throughout the design, like the rewards can be huge. What can be the rewards, basically? If you are using on data centers, the obvious thing is to optimize the costs, like hugely, let's say. Also, as I've talked initially, like you invert the dependency of the infra. So rather than you depending on the infra depends on you. However, there's a price you need to pay. If you don't integrate that risk management in the beginning, the technical debt will skyrocket probably. And since it is infra, most of the projects that I have heard like has been killed because of not managing those risks. So it seems obvious. What do you mean, like manage the risks? The problem is with Kubernetes, it is not obvious to most people because of this slide. So people expect quite the opposite from Kubernetes because it is powerful. So they have some expectations that really doesn't match the reality. So they went through all kinds of problems. So what we learned during this construction of this project is to explicitly manage those risks, because there are a lot of extensibility, which is powerful, but as I've said, it is a double-edged sword, basically. So making this explicit. But by the way, how do we do that? Like it is too generic of a term to make it explicit. What does that even mean? How do we make it explicit? So from the developer perspective, my idea was what I learned during the design of creating a production-ready large-scale entity was to be able to express to myself what I do, why I do, and in Kubernetes, if you are using some type of a specific resource, what are the other options that you can use instead of this resource, and why did you specifically pick that resource to use? So I forced myself and the team to make this as explicit as possible, to articulate this idea. So when we are basically trying to inject some resource as per some product requirement to our Kubernetes infra, let's say I picked resource X. So there are other options, Y, Z. We forced ourselves to think about why exactly we picked X and why we did not pick Y or Z. So to be able to answer that mitigated most of the risks, because it was kind of obvious what to expect when things go wrong. So after doing that, basically most of the project of design and implementing that started to become more fun, because we were managing the risks by that mindset from the developer perspective. That was the main learning, I would say. Okay, so that is basically most of it. Do you have any questions? The friend asked that the namespace is a resource that allows pods to communicate with each other without a constraint, which is true. So he asked that, how would the design be? Would it be different if namespaces did not support that? Yes, it would be drastically different. Actually, hierarchical namespaces kind of provide that out of the box. So you don't need to go about doing most of the manual things that I had to do, because it is an abstract entity, namespace. It doesn't prevent anything, but you can make it prevent if you want to, provided that you put the effort and like did that risk management properly. And the technique that I used, as I explicitly mentioned, was to delineate all those options and explain to myself and to my team why I used X instead of Y. So if that namespace supported this out of the box, then a lot of manual labor would be gone. So he asked, can you give us some examples of which problems you had with Kubernetes? So most of the problems was generated because of this. So our expectations did not meet the reality. For example, we started to play with, let's say, namespaces, right? But you realize when you play with it that it doesn't support anything. So what we try to do is to step by step, basically deploy partial clusters to AWS, to Google Cloud, to on-prem. So we understood that this is a huge labor. For example, this was one of the, actually it was one of the constraints that was close to killing all of the project, because even testing stuff, basic stuff, takes a lot of time. And what are you gonna do? Not test it? What are you gonna say to the customer? Hey, like we cannot test it right now. You can't, it is embedded. So we try to go with automation operators in Kubernetes. because of those problems due to manual labor, we try to identify several automation options, let's say, using specific Kubernetes operators. An example I gave you was actually Prometheus. Installing Prometheus was a problem. You wouldn't expect that. Like you're just gonna install a daemon. It's just logging. It's not in Kubernetes. It doesn't even support multi-tenancy. And we checked it. We didn't even see explicit mention of that, for example. So 1 week gone. Then we started to change the mindset of moving to automation as most as, as we can, for example. So we started to use operators as much as we can for everything, basically. I only mentioned Prometheus operator here, but there were other options too. So he asked that, what do you use to actually deploy Kubernetes to the clusters? Well, we had innate GitLab tools, and we had our own scripts to start with. To where those workloads were actually deployed was for AWS, it was EKS actually partially, and partially EC2 instances, depending on the specific requirements of that service as per the product definitions of the customer. For Google, it was GKA, basically. So Google Kubernetes Engine. So most of them were managed, but not all of them. And we started with generating our own scripts, actually. Why did we do that? Because we didn't know how Kubernetes worked when we started that. So there had to be, unfortunately, some price to be paid. Instead of using innate tools to generate that workload, producing, deployment, running, we started with our own scripts, because I had a DevOps team, dedicated DevOps team, so they were really familiar. I also had a SecOps team that helped with all those cryptographic stuff, basically. So writing scripts and generating them was not really problematic, as long as I provided the exact correct Kubernetes commands to run to them. So they would embed that to the script.